Hello, I'm Mr. Li Shenhang, a physics teacher here. In this video, we will set out to perform calculations around problems concerning freefall. Before starting, let's have a quick review on the physics needed for such calculations. Mind you, the following are just quick reviews of things taught before. If you have no ideas at all, you had better read the notes of the related materials. The first is that if air resistance is neglected, everything on Earth falls at a downward acceleration of 9.81 meter per second squared. The second is the so-called the equations of motion as shown below. They are equations that are used with motions having constant acceleration. Note that there are 5 variables involved in these equations, namely the displacement s, the acceleration a, the initial and final velocity u and v, and the elapsed time t. Note also that u, v, and a are vectors, and so depending on the positive direction you have taken, they could be positive or negative. Another thing to note is that while there are 5 variables, each of these equations contain exactly 4 variables. This means that as long as we know any 3 of them, the others can be solved. We just have to pick the right equations. In a while, we'll be using these equations to study freefall because objects undergoing freefall on Earth have a constant downward acceleration. And this is all that we need for the equations of motions to be used. Notice that we should put a equals to positive 9.81 meter per second squared if we take the downward direction as positive, simply because the acceleration due to gravity is downward. But a is equal to negative 9.81 meter per second squared if we take upward as positive. Now, let's apply the equations of motion to solve this problem. Consider a ball released from rest from the top of ICC, which is 484 meter high. Part A. How long does it take for the ball to reach the ground? Before any calculations, let's first settle on a positive direction. Since now it moves downward and accelerates also downward, it's just natural to take downward as positive. So that's it. Then, assuming that air resistance is negligible, we have A equals positive 9.81 meter per second squared. This positive sign comes from the fact that the acceleration due to gravity is downward and we have taken downward as positive. Next, its displacement s is shown by this arrow pointing from its initial position to its final position, and so it's downward 484 meter. As we have taken downward as positive, displacement s is equal to positive 484 meter. Finally, the word released from rest here implies that the initial velocity u is 0 meter per second. Now that we have known 3 variables, we can choose the right equation to solve for the problem. With known s, a, u, and looking for time t, we should use this, s equals ut plus 1/2 at squared. Putting in these values, we have this equation. Solving it as shown, it equals 9.93 seconds. Next, part B. What's its final velocity when reaching the ground? Before talking about the correct treatment of this problem, do you have this doubt like, hey, it reaches the ground and of course it comes to rest. The answer must be 0 meter per second. Then what's left for us to calculate? Alright, this is one of the most common misconceptions for many beginners. When I speak of its velocity when reaching the ground, what I mean is its velocity at the moment just about to, but not yet hitting the ground. Roughly speaking, it's the last moment just before it touches the ground. That is, the final velocity v of the free fall. So, instead of being at rest, at that moment it should actually be moving at its highest velocity instead. Anyway, now that we know it is v that we are after, we can move on to calculations. One way is to use this v squared equals to u squared plus 2as, as u, a, and s are all known. Anyway, putting the values into the equation appropriately, we have this, and upon solving, this is the result we have, 97.4 meter per second. But if you are careful enough about the mathematics behind, you should have a question. There should be a plus or minus sign before this 97.4 meter per second. So why can't we just write down positive 97.4 meter per second? The answer is we have taken downward as positive, and from common sense, you know that this ball is falling downward before the moment it touched the ground. So positive 97.4 meter per second means downward 97.4 meter per second is the answer.